Here we are given limit of a rational function equal to 0. Okay. What is a rational function? Rational function is a ratio of two polynomials. Here this is a ratio of polynomial and there is a polynomial. Basically, if you multiply x plus 1 and this ax minus b, this will give a quadratic, and quadratic plus quadratic is again a polynomial. We can convert this into ratio of two polynomials, right? Rational function we are given. Now limit x tends to infinity. What does that mean? It's a horizontal asymptote. We discussed about horizontal asymptotes of rational functions. What did we discuss earlier? We discussed that if a function is a ratio of two polynomials like this, right? Obviously a, n and bk are not equal to 0. That means the coefficients of highest powers. What is the highest power? Highest power is x power n here, right? And if n is not equal to 0, that means highest power is x power n here and x power k here if bk is not equal to 0. Obviously, when n equal to k, right? For example, this is of x square, highest power is x square, here also highest power is x square. Then a n by bk, that is the coefficients of the highest powers, which are all equal powers. That is, that horizontal line is the horizontal asymptote, right? If k is greater than n, that means n is less than k. That means the upper one is of degree 2 and the lower one is of degree 3, 4, 5, whatever. Then what will happen? Then horizontal axis, right? X-axis is the horizontal asymptote. And what happens if n is greater than k? This, right? So this one, the numerator will grow much faster. For example, if x power 5 is here and x power 3 is here, then the x power 5 will grow much faster than x power 3. So there will not be any horizontal asymptote, rather this will tend to infinity. Right, we all discussed that. When x tends to infinity, what is the horizontal asymptote? Horizontal asymptote is when x tends to plus infinity or minus infinity, that is the thing. Right, basically limit x tends to infinity is actually a horizontal asymptote. Now here we are given, here for this case, for this rational function, horizontal asymptote is 0. Obviously, what does that mean? The denominator, the highest power of denominator should be greater than highest power of numerator, right? That's what we are saying, right? K should be greater than n. Otherwise the numerator will grow much faster and it will not go to 0, right? Now if you expand this, or if you do this multiplication, what will happen? We'll get x squared plus 1 minus of ax plus b into x plus 1, right? So we can do this multiplication, right? Minus of, what will this become? Ax squared plus ax plus bx plus b, right? Now if we take x square common, x square times 1 minus a, this one, right? And minus a, this is minus a, and this b, minus a plus b, minus a plus b into x, and this one, and this minus b plus 1, right? This one will simplify to this one. Now this is a rational function, right? The numerator is of degree 2, denominator is of degree 1. Obviously, if it is of degree 2, then limit x tends to infinity, this will go to infinity, right? You want numerator to be lesser than denominator. Denominator of numerator should be lesser than denominator. Then only it will converge to 0, right? Then we can divide it by x, and then the numerator also we can divide it by x, etc., etc. Right? This is a rational function. What does that mean? The highest coefficient of x of the numerator should be lesser than this. What does that mean? These two should become 0 automatically, right? Then only x square will disappear, then only this x will disappear. We will get constant by x plus 1, then x tends to infinity, that will become 0, right? Now what does that mean? 1 minus a is equal to 0, that means a equal to 1, and a plus b also equal to 0, that means b equal to minus a, b equal to minus 1. Very simple problem, just that we are using the theorem of horizontal asymptotes, the result of horizontal asymptote, this one, right? What is a horizontal asymptote? When x tends to plus or minus infinity, how will this function behave, right? If it is a rational function, that is ratio of polynomial, then plus or minus infinity will give the same horizontal asymptote. There will be only one horizontal asymptote. Otherwise, maximum 2 can be there. Right. One when x tends to infinity, otherwise x tends to minus infinity. Right. But if it is a rational function like this, there will be only one. Where plus or minus, it doesn't matter. It will still give only one result. Right. If it is not a rational function, if it is some other function, at max 2 horizontal asymptotes we can have. What about vertical ones? Vertical ones we can have as many as we want. Right. For example, x square plus 2. By we can write it as x minus 1, x minus 3, x minus 5, whatever we write, wherever denominator is happening, right? There's a vertical asymptote whenever it is not a common factor. But horizontal asymptotes, we cannot have many. We cannot have many, right? Horizontal asymptote is when x tends to infinity, we can x tends only once, right? We cannot have multiple times when x tending to positive infinity or negative infinity. So that's why there is only one horizontal if it is a ratio of polynomials, or otherwise also one for positive x, another for negative x. Right guys? Hope you like this. Thank you.